pretty close to the top now. All right, here we go. Thank you, because there's 3 people absent in the other class, so it's a good idea to record. All right, so when we do stoichiometry, the first thing you always have to do is balance the equation, and that's why we've been spending a week and a half on naming so that we could end up getting a formula, so we could end up balancing, so now we can do math. This is the end game. All right, we've been doing all that for this. Now this isn't working. Oh, this makes it so much harder. It's got to move closer to the thing. See what happens when you're my favorite student? All right. Hopefully it will read now. Because when it's off time, it's impossible to write. All right, so we're going to balance this equation. So we have 2Cl, so I put a 2 right here. That makes 2Na, so I put a 2 right there. And then I have 1Cl2. So the first step is to always to write out and balance the equation. Step 2, find the molar mass of the needed species. What we mean by needed are the ones that are in this problem. So it says how many grams of salt. So I'm going to need that one. Can be formed if you have 36 grams of sodium. So I'm going to need that one. Remember, the molar masses come from, this is for sodium. It comes from the periodic table. You'll have your Na. You'll have your 23. You'll have your 11. It's the bigger of the number. So that's where the 23 came from. Then we have to find it for sodium chloride because that's salt. So we need to add 2 times what chlorine is, and chlorine is 35.5 and 17. When you do that, no, you don't need 2, sorry. The 2's here, not, ignore me. I was multiplying it by 2 because I did it that last hour. This one's just 1. So it's 23 plus 35.5, which makes my 58.5. Are we okay so far? Tell your lab partner if you're lost or not. For real? Were you here yesterday? Okay. All right. So I have 2 people within my ear, and they're both lost. So here we go. A formula consists of the chemical symbols. To find the mass of it, we look on the periodic table for the large number in the box. Sodium is 23. But there's also chlorine. So I look at chlorine. It's 35.5. So I add both pieces, and I get 58.5 grams. And anytime I find the molar mass from the periodic table, we said it was per what? 1 mole. So that is the number that is going right here. And then for sodium, it was just the 23 because it's just 23. Okay, I'm going to erase most of this. Remember, it was a 2, a 1, and a 2. Now, the next step, even though I misnumbered it, whatever, it says set up picket fence with given number and unit at the top left. All right, so that means we're going to go here. So I take the number and the unit that was given to me in the problem. If you look, here is a number, and then the unit is right after it. And please, you cannot be lazy. It will really kick your butt later if you are. So I'm going to take 36 grams. And that's 36 grams of what? Of sodium. So I need to put the whole thing, 36 grams of Na. The reason I'm putting the whole thing is because of this idea back here that says we are going to use the fact that if something's on top and the bottom, we can cancel out. So what I'm going to do, I want to solve for something besides grams of Na, so I need to get rid of it. So I move this unit over and down. So I have grams of Na on the bottom and to the right. That is so I can eliminate that unit. But there has to be something on the top of this fraction, and I find it, look at the screen for a second, I find it right here. There is a ratio that says for every 23 grams I have, there's one mole, and it's the same thing, Na. Now I'm going to jump to the end for a second because I should have done this earlier. What are we solving for? Grams of sodium, no, of salt. Grams of NaCl. All right. So now I look, and are moles of Na grams of NaCl? No, they're not the same thing. So I have to eliminate them. So look at the screen, please. We're taking advantage of the fact that if something's on the top, I can cancel it out if it's on the bottom. So I just move mole of Na over here. All right? But then this fifth rule, even though it's misnumbered, if you ever get stuck, then go to the end and work your way until you meet in the middle. So we're going to go this way. And we're going to say something that we're going to say a lot, and it sounds stupid. Are you ready? Please repeat with me. The unit at the end is the unit at the end. You're welcome. Now, what that means is if I'm solving for grams of NaCl, it's the same unit that's at the end of this thing we call a picket fence. The unit at the end is always the unit at the end. All right, now, looking up here, I have a ratio that I can put in my picket fence that says for every 58.5 grams of NaCl, I have 1 mole of NaCl. Now we have one last part to fill in. If you look at the screen, this unit right here has to match that unit up there. So this tells me that up here I have mole NaCl. No. So now, well, mathematically they'll reduce to ones, but they're not ones yet. So please look. This step, and I have it in this bluish rectangle, this step is called the ratio of coefficients. And let me scroll up a tiny bit so you can read that better. The ratio of coefficients is the ratio of your balanced equation that compares the moles of what you want on top, and you can see that we want NaCl, so it's moles of NaCl on top, to the moles of what you were given on the bottom. I was given Na, so moles Na has to be on the bottom. This is the step that requires us to have a balanced reaction. So these numbers right here, they come, don't write an 8, hopefully that's not confusing. They come from right up here. So if you look, what number is in front of NaCl? A 2, so I put that in front of NaCl. What's in front of Na? A 2. Now, mathematically, 2 and 2 just reduce to 1. So mathematically, that step was not important. But that is not how it always works. So you have to always have the ratio of coefficients. Okay, now, please look at the screen for a second before you do anything else. I'm going to reduce these. Go ahead. I'm going to reduce these to 1s just to save me some steps in my calculator. All right. Now look. This whole process, we were taking advantage of the fact, look at the screen, that a unit on top and bottom can be canceled out. This one cannot cancel out, but that's fine because the unit at the end is the what? Unit at the end. And if all units cancel except for the one I want, then I probably did this right. Now, mathematically, you should do this very technical. You take 36 times 1, which I know we don't need to, times 1, which I know we don't need to, times 58.5. You multiply the entire top, then you multiply the entire bottom, 23 times 1, whatever, and then you divide the two answers. So to just write this out, it would be 36 times 58.5, and then that would be divided by just 23 because everything else on the bottom was a 1. And what do you get? 91.56 or something like that, right? What do I do with what? The bottom left square, 99% of the time is empty on purpose. We do some problems where there is something there, but that's not for a while, so just leave it empty. Sort of. It's when your given itself is a proportion, and it's only when we use molarity. Yes, Diane? Right here? No. The 2's come from here, which means we have a 2-to-2 ratio when Na reacts with Cl to produce NaCl. Well, you said grams. These have nothing at all to do with grams. If you said the word moles, then I would have said yes, probably. Okay. Now, I don't think that everyone's 100%, so should we practice some more? All right, here we go. All right, I put this in blue again because this is your ratio of coefficients. Here we go. So the first thing we have to do is to write out and balance this equation, which I'll do for you. So how many grams of iron are required to produce 80 grams of iron 3 oxide? So what am I producing? Iron 3 oxide. Fe and O. What's the charge of Fe here? Plus 3, what's O? Minus 2, so it's Fe2O3. And then what things must have made this? There's only 2 reactants. All right, you have to have the 2 other pieces, but one mistake kids make all the time is right here. Oxygen is diatomic. And then will you take 30 seconds and balance it? Okay, that was 30 seconds. If you didn't get it that fast, it's okay, but we're going to do it for time's sake. If you see a 3 and 2, you should use the swapperoo. The 3 goes in front of the 2. This 2 will go in the front of the thing with the 3, and that makes 4 of these. Okay, so that's step number 1. Step number 2, find the molar mass of the needed species. So we come up here. There is iron and iron 3 oxide. So I have to find the mass of this and then the molar mass of this. So iron is very simple. You just come down. Iron is in a box. It's Fe, and it's 56 grams per mole if you round it. No? It's okay. Then iron 2 oxide. Some of you still need a lot of help with that. So iron 3 oxide. I'm going to break it down. There are 2 irons, and each iron itself is 57. I'm going to add 3 oxygens. Everyone's looking over there making me think I'm wrong. Am I wrong? 56. I had a feeling when all of you looked like, what is he doing? 56 is what I put. All right. And then 3, and then I know oxygen is 16, so I feel confident with that. Is it 112? Okay, good. Shoot, not 112? Oh, 112's coming up later, sorry. What is it? 172? I'm doing this math. 112 plus 48, 160. Well, it's sort of right at 112. I just forgot the other half. Okay, so this is 160 grams per what? 1 mole. Now, will you give this 2 minutes and try it yourself? We'll work through it together, and I know some of you still have no idea, so just wait and enjoy the next 2 minutes of your life. All right. Once again, if you're not 100% with me yet, that's normal. I don't expect you to be 100% with me even today. But hopefully, for each one of you, it kind of clicks as we go along. So I balanced, and I found the molar masses. So step 1 and 2 were done. Step number 2 of number 2. Set up picket fence with given number and unit in the left. So I find my number is right here. It's 80 grams of what? All right, of this. Fe2O3. Now, you're a teenager, so you don't like to do more work than you think you need to do. Don't get lazy. Please take the entire unit down here. If you don't take the unit, then you get lost what's up here, and then you're lost what goes there, and it's a disaster. All right, grams are always per what? 1 mole of the exact same species. And then whatever unit is here always goes down there. So I know that I have mole of Fe2O3 on the bottom. Now, some of you might already know what goes on top, and that's fine. Do it. If you don't, and this is how I do it, just from habit, I go to the end and I work the way backwards now. So I'm solving for grams of Fe. And the unit at the end is always what? The unit at the end. And grams is always per what? 1 mole of the same species. I found this number earlier. It was right here. 56 grams of iron for every 1 mole. And then the unit down here has to go up there, so they can cancel out. So I have mole Fe. And then I just need to find these 2 values. And I find those up here. There's a 4 in front of iron, so I put a 4 right here. And there's a 2 in front of Fe2O3, so I put a 2 right there. Now, math-wise, I'm going to reduce 4 halves to just the number 2. Oh, thank you, I did not. And that was just this number right here, 160. Okay, thank you. Now, math-wise, like, did anyone type this in and have a heart attack? And think, it can't be that. Math-wise, you take 80, multiply it by 2, multiply it by 56, and then you divide by 160. But here's something cool. What is 80 times 2? 160. What's 160 divided by 160? 1. So you really have 1 times 56. Now, if the math I just did right there didn't make sense, just type it in your calculator and you'll be fine. All right. Wasn't that fun? It was easier than the first time. Thank you. So hopefully the third time's even easier. Here we go. All right. I'll help you with the chemistry. If you have 65 grams of magnesium, what is the max amount of magnesium fluoride that you can make? All right, so here we go. What am I making? Magnesium fluoride. That's what I'm looking for at the end. Now, what's magnesium's charge? 2. F is A. 1, so it's MgF2. What two things must this have been made out of? All right, you guys like these easy ones, the last two slides? Magnesium's diatomic, so this one is very easy to balance. Okay, I will help you. Magnesium is 24 grams per 1 mole. Magnesium fluoride, I think, was 62. Yeah. Okay, you try the rest. All right, if you did not get this answer, please make sure you're paying attention. 65 grams of Mg, because that's my given unit and number. 24 grams of Mg for every 1 mole. And I simply got that from the periodic table. Mg is 24 grams per mole. Down here, it has to match, so it's mole Mg. In this one, it's very simple. They're all ones. Oh, I forgot to record. All right, so these match right here, mole of Mg on the bottom. And that's where I get stuck. It's always in this ratio of coefficients. And some of you don't get stuck because you figured it out, and that's fine. So now I go to the end. My 167.9 grams of what was I solving for? That was my MgF2. So grams of MgF2 comes here. And grams is always per 1 mole. MgF2. So what does that mean up here? All right, mole MgF2. That's a 1 as well. So the last thing I got to do is put a 62 right here. 65 times 62 divided by 24. Now, I need to warn you of something that kids do all the time. Now, this problem doesn't have this problem, but I'm going to talk about it anyway. If, so just if for a second, if this was a 2, your calculator will hose you over. If you take 65 times 62, and then you divide it by 24 times 2, you will get the wrong answer every single time. If there's 2 things in your denominator, they must be in parentheses. Because if not, you're finding the answer of the first 3 things and doubling it, when in fact you were supposed to half it. So you're 4 times off. So make sure you do the order of operations correctly. If you don't use a calculator with a lot of stuff, multiply the top, write the number, multiply the bottom, write the number, and then divide those 2. It really does get you. All right, I'll help you with this equation, then you have to do the rest. 38 grams of aluminum are burned or heated, really. It doesn't light on fire, but whatever. And it produces aluminum oxide. So what must this missing thing be? Oxygen. All right, this is a 2-3 swap. 3 in front of the 2, 2 in front of the 3, 4 in front of the AL. Solve me a picket fence. What's that? No. I'm looking for how many grams of Al2O3.